Hello, everyone. Thanks for joining this session. You are in session BOA319, and we will discuss about .NET, .NET MAUI, Blazor WebAssembly, AWS IoT Core, AWS Lambda, Amazon DynamoDB, and AWS AppSync, all together to build a cross-platform interactive poll application. So, let's start with a bit of context before jumping into the details. I would like to explain how this idea has started. Last year at re:Invent, we were excited to go back to in-person event and to meet you all. I was a staff member at the developer lounge in the expo area. I was tasked to welcome attendees to our booth, answer their questions, and explain and present our AWS community programs. But attendees were walking in front of our welcome desk, gave a quick look, and moved away. I was, oh my God, what's wrong with me? Is my terrible French accent so awful? So we were definitely missing an icebreaker activity. So we've fixed this. We started to run polls at the welcome desk. And when I say at the welcome desk, I should say on the welcome desk. We asked attendees for their favorite swags, very popular questions with great suggestions. We also asked for their jobs, for their favorite programming language, a very controversial question, and for AWS, the AWS service they want to try. It really helped us to break the ice and engage meaningful conversation with attendees. So we knew that we will renew this experience this year. But you know, we are geeks. So we start to think, what if attendees could come at the developer lounge, vote on touch screen, and see the results on a real-time dashboard on a monitor? That's what we've imagined, and that's what we've built. So if you come to the developer lounge this week, you've probably seen these touch screens on the welcome desk, and you've probably been invited to go at the DevPulse kiosk to see the live dashboard. So we've built this application. Now you've seen the application. Let's discuss how we've architected this. So attendees use the tablet to vote. Each time they vote, it sends an MQTT message to AWS IoT Core. IoT Core is a managed IoT service that offers message broker capabilities. It lets you connect billions of IoT devices and route trillions of messages without managing infrastructure. So here we are all good with our three tablets. Once AWS IoT Core has received the message, it will route the message based on the AWS IoT rules we've defined. Here we trigger AWS Lambda. AWS Lambda is a serverless, event-driven compute service that lets you run code without provisioning or managing servers. The service will instantiate one or several AWS Lambda functions to process incoming messages. The functions will store every message in a Amazon DynamoDB table. Amazon DynamoDB is a fully managed, serverless, key-value NoSQL database to run high-performance application at any scale. Whether you have a high-traffic application or low-traffic application, it can fit your need. We store every message, so basically every vote, in case we would like to audit the results. Amazon DynamoDB has a feature called Amazon DynamoDB Streams. It captures time-ordered sequence of item-level modification and stores this information in a log up to 24 hours. The nice thing comes when you realize that you can integrate DynamoDB streams with AWS Lambda and trigger a Lambda function for each item modification. In our case, we trigger a Lambda function each time a new vote is stored to update the total number of votes for an answer to the poll. So Derek, here, is in charge of the front-end team. Jose is in charge of the back-end team, and I'm in charge of the DevBuild dashboard. So the dashboard query data to AppSync. So AppSync is oh my God, sorry about this. Let's come back. Okay, give me a second. Okay. So it queries a GraphQL API. So the dashboard query a GraphQL API to get the poll results. So we use AppSync to serve our GraphQL API. It's a serverless GraphQL and PubSub API service. AWS AppSync integrates with DynamoDB to resolve the data that we request. The dashboard also subscribes to get notification of each mutation of the data. The GraphQL mutation operation is called by a Lambda function that is triggered each time the number of votes for an answer is updated. And that's it. We have our end-to-end architecture. So to implement this application, we use .NET because the three of us are .NET developers. On my side, I'm a .NET developer for more than 15 years. I've started to code with C# and .NET for building pen-based software on Windows XP tablet PC a long time ago. Since then, I've never stopped to use .NET. I really love the motto of the platform, any app, any platform, and I think .NET 7 brings us closer to these goals than ever. I've been a Microsoft MVP for Visual Studio. I worked at Microsoft, and now I'm a .NET Senior Developer Advocate at AWS. My day-to-day job is to help .NET developers to leverage AWS services in their application, and as well as being the developer zero for our service teams when it comes to the .NET developer experience. And what about you, Jose?
Well, Francois, in my case, the first programming language I ever developed on was Visual Basic when I was 13 years. So I had kind of an attachment to Microsoft platform from the beginning. But then I changed my mind in some things. I went to other solutions, and 15 years ago, I came back to C# working at Microsoft. So right now, I'm focused on backend solutions and mostly containerized solutions on .NET. And what about you, Derek?
Well, Jose. Hi, everybody. My name's Derek. I'm the front-end guy. So what I've been building .NET apps for probably about 12 to 15 years. I built a startup on .NET, and it was fine for a number of years until I ran out of money. But over the last 4 or 5 years, I've been trying to champion .NET development on AWS, and this talk is here. Has anybody actually used the app in the expo? Couple people? Is anybody a front-end developer? Yes, we've got one. We've got a couple. That's excellent. So I'm going to go through the front end and what it was built with and how we built it. And then throughout the talk, Jose and Francois will do their sections as well and give you a good picture of exactly how this was built. We'll even go into some code. Warning, there is code in this walkthrough. Some people might like it, some people might not. But bear with us. So what we're going to do is, as I said, go through all of the tiers of this application. Think about our design. Why did we choose a particular technology for a particular tier of that application? What are the benefits? What are the drawbacks? What are the speed bumps along the way that we faced when we were building the application? So hopefully when you walk out the door at the end, you'll know exactly how to approach a similar problem. So let's get into it, the front end. So those of you who have used the application, you'll know that I'm not traditionally a UI guy, right? So the UI needs a bit of work. I'm a developer, so it is very much built by a developer. So as Francois mentioned, the front end is MQTT, so it's actually built in Maui. So .NET Maui, is anybody used either Maui or Xamarin? You got a couple? Awesome. So anybody who hasn't, Xamarin was released about 7 or 8 years ago, or actually acquired by Microsoft. And it is a cross-platform application framework where you write code once. It's like the promised land that everybody promises. Write code once, ever since Java 1. Write code once, run it in many different platforms. So Xamarin came out, and then this year, .NET Maui was released, which is Xamarin, I would call it Xamarin 2.0. And so what that cross-platform Maui app allows us to do is to run the application on the tablets. And how the application connects is using MQTT to AWS IoT Core. So Maui also supports .NET 7. So .NET 7 came out 2 weeks ago. It was actually released 2 weeks ago. So me being me decided let's upgrade this app that I've been building to .NET 7, and it actually worked first time. So I was pretty happy with myself when that came to fruition. So this Maui app is actually built in .NET 7. It supports hybrid and native. So the main difference between what was traditional Xamarin and Maui is you can run hybrid apps using Blazor inside a Maui container. So you can run a pure native app using Maui, or if you want to run a hybrid app, you can do that inside Maui. Now, I had a little bit of help when I was building this app. Luckily, there is a fantastic toolkit. So if you're if you're thinking about Maui, the Maui Community Toolkit is you must use it. It is fantastic. It makes life so much easier. So when you're thinking about binding objects to the UI, how to run events, commands, then the Community Toolkit actually covers all of that. And all you have to do is annotate your view model, which is fantastic. And the creator of the Maui Community Toolkit is Brandon Minnick, who now works for AWS and helped me build this app, which is pretty cool. So thanks to Brandon, you've been fantastic. So Maui Community Toolkit, you'll have a good day. So I've been on the booth with this application for the last 3 days. And the biggest question have been asked is, Derek, why are we using MQTT to do client to backend? Well, the answer's here in 3 very easy to read bullet points. First one, we're in a expo hall. There are I don't know how many other exhibitors there, and there's thousands of people all connected to the Wi-Fi. That Wi-Fi is going to drop out. Come on, you're being very optimistic if you think it's not. So an inconsistent network is bad for, say, traditional techniques that you may use, say a RESTful client-server sort of architecture. So that really rules out an API gateway in your backend, and to the same extent, AppSync, managed GraphQL service, because both rely on the network connection being reliable. So another benefit of MQTT is you can actually use the MQTT protocol and cache results locally. So what does that mean? Well, you've started to build in resilience to your client application. So as a user, if you select an answer, the answer is cached locally if we can't connect to the back end, right? So as a user, if the network's inconsistent, you never see it. So you never see any errors. You never see any things bad happening, so you have a good experience. And so you can, with that cache working as a store, when the connection to the backend reestablishes, the cache flushes all the answers. So not only does the user have a great experience, but also we get all the answers. So all of the data that we've collected gets flushed to the backend using MQTT. And the library I use to build all of this is MQTT.NET, which is an open source library you can get on GitHub. And what MQTT.NET has in its API is all driven by a factory method. So it's really, really easy to implement. And it also has an extension method, which is a managed cache version. So I'm like, this is like gold. This is going to make my life so much easier. So next, after we've established that we're going to use MQTT to IoT core, we need to think about security, because security is job zero. So how do we secure our clients to the IoT core service? So with IoT core, you have three options. You can either use IAM policy and roles. You can use Amazon Cognito to allow you to log in with user ID and credentials. Or you can use X509 certificates. Now, ideally, you would like to use Amazon Cognito because that would make it easier for you to have a username and a password that would then secure that device. And so you wouldn't have to install certificates on the device, which is unwieldy and it can take time. However, I didn't have time to build a username and password, so I fell back to installing certificates on the device. And that secured the device and was enough to satisfy the requirement of security. But if I had more time to build this again, I would probably use user credentials to secure it. So these are the gotchas that I ran into when I was building the connection between IoT, the client and IoT core. So first thing I had to figure out was connections and connection strings. So with IoT core, you have to provision clients. And every one of our devices is an individual device, an individual client, and that way we can provision a certificate for each one. And that was easy. But finding the actual endpoint URL is lost in the console. You can actually find it. So finding that URL is actually under the IoT, general IoT details. And so if you go into test IoT client, you will find the endpoint. Next gotcha is client ID uniqueness. So you need to specify a client ID that is unique for each client. So the client ID needs to be static for each client, but it needs to be unique. Otherwise, you will get random errors. And some of your messages will not be consumed, and you will have a very bad day debugging it. So be warned. Next, enable CloudWatch logs for IoT by default. It's not enabled by default, so you have to enable it when you when you work with IoT. This allows you to then figure out what's going on. Tune Keep Alive. So Keep Alive is an MQTT construct that specifies how long you can ping the server to make sure your connection, keep the connection alive. This is a judgment call. So I wanted the Keep Alive to be long enough, but I also wanted to check the network connection. Because if I didn't do that, then when I sent a message, the client would think it would still be connected, but it actually wasn't because it wasn't checking. So you have to tune that because if once it knows it's disconnected, it pushes everything to cache. So you have to bear that in mind. And then finally, use the managed client extension that comes with MQTT.NET. It saves you a lot of problems. Saves you a lot of problems. Another thing is anybody use the backends for front ends pattern? Yep, few nods. So this pattern I've known for a number of years, and it's all about, it can be confusing because it says backends for front end, but it's not the entire backend. It's just the backend that services that particular client type. So in our particular use case, we had a MAUI client and an IoT core backend. And I could happily develop that in isolation from Jose, who was doing the real backend. And if there was another front-end developer who was building a web front-end, they could use the backend for front-end pattern to build a backend, a front-end in the web that could connect to API gateway. And we could do that in isolation because we're using that backend for front-end pattern. My backend as the MAUI developer was IoT core. If I was instead the web developer, my backend would be API gateway, if that was our chosen technology. So the backend for front-end, although it sounds confusing, it's quite powerful. So bear that in mind. And also the advantage is I am the developer advocate for Australia and New Zealand. Jose is in Peru, and Francois is in France. So we are completely geographically diverse. So working in isolation and able to do our user stories in isolation and be able to test them is very, very important. So this pattern really shines. So I'm going to now go through a bit of the code and take you through what it looks like. If I can work the buttons. Yes, I can. So I'm going to show you in Visual Studio. For Mac, I actually built it on Visual Studio for Windows, but the code base, because Mac presents better. So this is the entry point to a MAUI program. If you've used .NET before, you'll see that it uses the beautiful inversion control, where you can inject the objects that you need, and then you can use those types in any constructor. And so I'm adding the pages. So we've got one page here, which is the question page. And we've also defined a service called MQTT service, which I'll go into quite a bit of depth into, and also the question service. So the great thing about this project is it's actually an MVVM project. So models go in here, views are here, and view models are here. So if you're building a MAUI project, this is best practice. You should absolutely use MVVM, and also it allows you to benefit from the power of the community toolkit. So I'll quickly go through a view so you see it. So we've got one page. In MAUI and Xamarin, in MAUI, you define UI is XML. And it's a very simple page. There's not much to it. There's a handle selection changed, and there is some UI. It's actually a grid, so it's a grid of 2 columns. Very simple. The one that's really interesting is then inside my view model, which handles that page. I have got my 2 services, my question service and my message service. Now my question service, basically when the app loads, we need new questions. Now, again, due to time constraints, this could have been an API call. You could have served very much like building a random joke generator. This could be an API to a third-party app, which could serve you questions. For my intents and purposes, it's actually the service itself just reads a static file, which is the questions. What's interesting is the other service, which is the message service. So if I open my services folder into the message service. So here I'm defining a few things that I need to get MQTT working. I've got my certificates. I've got some settings. So I've externalized some of the settings, like the IoT core endpoint, the client ID. So I can then, as I deploy this across different clients, I can update the client ID at deployment time, so it's unique. Remember, uniqueness is key when it comes to client IDs. I also have the topic name. because I'm publishing these messages to an IoT core topic. Then I've got the actual send answer, which I'll go through in a bit. But first of all, I've got the initialize the client. So as I said before, this is using the MQTT net library, and it is a factory method. And all I do is load my settings, define, again, this is my timeout and keep alive. I've termed this to be 5 seconds. So I've said every 5 seconds, check the connection, and then set up the X509 certificates, and then deploy the managed client, which allows me to actually define the cache, where the cache lives on the device. So then, once I've defined that, I simply then define a send answer, and all it does, grabs my message that the answer that I've grabbed from the UI, serializes it, and sends it to the topic that I've defined. And that's it. That is all the code for the MQTT service. In its entirety, I've got some connectivity checks, but it's 170 lines of C# code. Very easy, it's resilient, it sends messages, it'll reconnect, it'll do the cache. It's pretty cool. So that's the MQTT net library. Back to the questions, and that's the client through MAUI, MQTT net library using the extension method into IoT core. Now I'll hand over to Jose to go over the backend.
Thank you. So it's now time for the backend. As Francois mentioned at the beginning, we have an MQTT topic that we are using through IoT core. We can have a Lambda function that reacts to the fact that we have a new message into that IoT core topic. So that made that quite easy to process. So we have that raw object that comes from direct client, and we have to process that so it makes sense for our application. So the first step will be we process that on a Lambda function, just storing the timestamp and the two attributes that we have, that is the question and the answer. And then, once that's stored, we use something called DynamoDB streams. So if you're not familiar with that, that means something like change data capture, you know? So once something happens there, it will trigger an event. And you can filter that event for example, we are writing something, we're changing something, we're deleting something, so you can personalize the events that you are using as triggers. We actually, to be completely honest, we didn't filter any events, so we are just streaming all the events happening from DynamoDB streams. It's not a good practice, and we filter that from code, but you can offload that compute from the Lambda function into DynamoDB stream, and it will work really fine. So once we have that event, we will use the same DynamoDB table that we used at the beginning, but now with one more attribute, that is the counting. Okay, so we're going to show you how it works in the code walkthrough. So just a little abstract of what we did. The client sent the IoT event, the backend reacts through Lambda, and then the functions get an object. Okay, and I want to ask how many of you are already using C# with Lambda functions today? Okay, some of you, and that's good. But in my case, it was the first time. I told you, I am a container guy. I was using Kubernetes, and I was using ECS, and I was using Copilot, and I was using CDK to do my stuff. So how it works for me? For me, it was kind of a chaos. It was complicated to understand how I can do it. So if it's your first time or you're just starting, I believe this is going to be kind of worrying. The first, you need an IDE, right? So it could be Visual Studio Code, it can be Visual Studio, it doesn't matter, it depends on you. If you like visual stuff, Visual Studio Code is clicks, and it's really easy to complete. But if you are a VS Code person, maybe you can use the CLI that we have. So you just need .NET 6 SDK and Lambda tools. So once you install Lambda tools, you are going to be able to install Lambda templates that let you choose from 33 kinds of templates that are available. Some of them are a basic API. The others are how to react to an MQTT event or an IoT button or working with recognition or any kind of examples that you can use as template to create your own stuff. So it's really, really straightforward and easy. You can now run on your CLI to create the function that we create, a .NET new Lambda empty function that will get you a basic structure. So that's the command that I use, specifying the region and the profile. The profile will be pretty much the CLI profile that we use for the current session. Okay? So what I will get once I run that command, I will have this basic function structure. And some of the things is we're getting a J object. Okay? So what does it mean? If we create a trigger from an IoT core that is coming as an MQTT message, that message will be, in our case, a JSON request. So we can do two things. The first one is we can have a class to deserialize that object and have something like cool to work with using the variables. Or we can use a loosely typed object, like JObject, and we don't care about the class. I use the JObject because it was really straightforward. We were getting just two parameters, answer and question. Okay? And then we have the context. And the context, we use it to make some operations through Lambda by, for example, logging or having some HTTP responses. Then, once we have the function, we also need somewhere to store the data. So we are using DynamoDB. And why we use DynamoDB? Because the documental nature of the database. Remember, we have the same table that is called vote that stores the voting and also the aggregation. Okay? So for that matter, it makes sense to use a documental database. The other one is that we need near real time for this because we have near real-time results on the dashboard. And we need a low-cost and low-latency solution. We don't want to also complicate things with DBAs. Because we are backend developers, as you can see from our interactions, dashboards, and stuff, we are backend developers all. And Lambda already implement data change capture, as I said. And something really good is that when you have a data change capture in any database engine, you have to know what's the object or how is the structure of the data model from any event, right? Because you need to react to that event and parse that event how it comes. And something really cool is that C# with .NET Tools and the SDK of AWS actually include the class, so you don't need to parse anything. You can just use that in your Lambda function. And also, obviously, we need native support from the database and .NET. So it ends like this. Now we have the client. We have the IoT event that makes the backend react. We have the object that will be stored in DynamoDB. And once DynamoDB stores something, it will trigger a Lambda stream that at the end will follow the same process that we saw. So let's take a look on the code walkthrough. OK, there we go. So first, we're going to go to the basic one. That is the vote storage. OK, so it's the first step of the processing. Why it's called vote 2? Because we already have vote 1, and we don't want to play with Destiny. So we leave it there just in case. So we have vote 2. And we specify how that table going to be created. So first, we use headers from DynamoDB once we take DynamoDB data model. Okay, so that's the requirement, and we can do that with NuGet or .NET CLI. So we specify the hash key. That is going to be our key to query based on questions. Then we have the range key, that is the sort one. And we have the two properties that I said, that is answer, and finally the timestamp. So we can also filter by event. Okay? So that's pretty much how I specify a data table on DynamoDB. Then we have the most basic thing. So if you want to work with DynamoDB on Lambda functions on .NET, it's pretty straightforward. You just need to specify or declare first your DynamoDB client and context. And on the constructor, you initialize the database context by the client. Once you have that, we're reacting to the fact that we have a JSON object that comes every time an MQTT message is coming. We generate a new GUID that will be random because every vote will be unique, random and unique. And then we have the store of the answer that we are parsing through JSON object. As we said, we don't want to deserialize this, so we just use the attribute name there, and it will work. It's not pretty, and we're not validating the data, but it works to visualize how it works. So now we have the last attribute that is timestamp datetime now. So we generate the object, the vote object. And the only thing that you need to make to save that to DynamoDB is this line of code. So you can have any kind of logic and use that line of code to start storing on DynamoDB. So as I said, it's pretty straightforward and pretty easy. Now, let me show you what happens here. Once this is saved on DynamoDB, we can trigger Lambda functions through a DynamoDB stream. So you can add a trigger here on your Lambda function and specify what will happen. We have two here. I will just open one because the other one is disabled. And you can specify what table on DynamoDB will be the trigger. So you need first an IAM role that has the policy to access that table, and you specify how many records per time you're going to process. In our case, because we are processing one vote in order, we just have a batch of one. And finally, as I told you, you can have a filter here, so you can put a JSON with a filter criteria to specify if you want just the new record event, so you don't have that on the Lambda logic. So we have that, and the last step for us will be the vote aggregation. So because we don't have that attribute on the voting table, we check if the count is 0, and in that case, we initialize that with 1. Otherwise, we start counting down with +1. As you can see, we are not parsing things. We're just using this pretty object called DynamoDB event. So we can use that to have the whole structure and save time and code on that. So that's pretty much it on the backend side. It's pretty simple. And now it's time to the good part, the WebAssembly part.
Thank you, Jose. So let's talk about the live dashboard. The DevPulse dashboard is a single-page web application. But to be honest, my JavaScript skills are terrible. So how did I build a web application without JavaScript? Well, with WebAssembly. WebAssembly is a binary instruction format for a stack-based virtual machine. It is designed as a portable compilation target for programming languages, any programming languages. It has been designed first to run in web browser, but nowadays there are no initiatives to provide WebAssembly runtime that execute WebAssembly application outside the browser. It has been designed to be efficient and fast for the web. So the binary format is efficient from a size and load time perspective, and it takes advantage of common hardware capabilities. It has also been designed to be open and debuggable. So there is a textual format for debugging and testing purpose. It is safe by design, too. It describes a memory safe sandboxed execution environment. And more important, it is part of the open web platform. It means it maintains the versionless feature testing and backward-compatible nature of the web. The open standards for WebAssembly are developed in a W3C community group and a W3C working group. And today, WebAssembly is shipped in 4 major browsers: Firefox, Chrome, Edge, and Safari. And the .NET team, and especially the .NET Web team, has seen a huge opportunity to enable .NET developers to build modern web applications with their C# and .NET skills, like myself. They've extended their component-based Blazor web application framework to support WebAssembly. So Blazor WebAssembly enables .NET developers to build client-side interactive UI with C# and share code and libraries between client-side app and server-side app. So yes, C# code running inside the browser without any proprietary extension. So it's not Silverlight for those of you who remind about Silverlight. Now it's built on open standard. And in case you miss something, you can leverage JavaScript interop to fall back to JavaScript libraries, for example. So to build our single-page application, we've used a Blazor component library because we didn't want to redesign every component by ourselves. Material design is a very popular design system created by Google. It has been widely adopted on the web, and users are used to this design system. So relying on it helps end user to quickly understand your web application. So that's our choice. And when it comes to Blazor, there are a couple of Blazor component libraries that are inspired by material design, but the most popular is certainly MudBlazor. It is highly customizable, and they chose to use only CSS and SASS and no JavaScript to minimize the JavaScript interop, because you have a penalty when you use too much the JavaScript interop. But to be honest, their component libraries is awesome, but their chart components are still behind JavaScript chart libraries like Plotly.js. So for charts, we've used Plotly.blazor. It's a Blazor component library that wraps Plotly.js for us and already take care of the JavaScript interop. So both libraries are licensed under the MIT license. Our live dashboard is a very data-centric application. We want to be updated in near real time of any poll result update. To do this, we need to use a synchronization mechanism. That's what GraphQL subscription operation is all about. GraphQL is a query language and a runtime to run these queries. It allows to query data and specify exactly which properties you want to get. In addition, it provides a subscription operation that allows to subscribe to data update. Your client app can call a subscription operation and then get notified to data updates related to this operation. On AWS, you can leverage AWS AppSync to implement your GraphQL API. You just define your GraphQL schema and create what we call resolvers that define where and how you retrieve and update a piece of data. And that's it. The service will expose and manage your GraphQL API for you. To consume our GraphQL API, we need a .NET GraphQL client library. We've chosen Strawberry Check GraphQL client library. It is developed by Michael Steb, a GraphQL technical steering committee member and a Microsoft MVP. It is open source and licensed under the MIT license. It is compatible with all GraphQL compliant servers, and it removes complexity of state management and interaction with local data and remote data. There is a small downside with GraphQL specifications. The specification is not bound to a transport. For query and mutation, most implementation rely on HTTP transport, but for subscription, it's a bit more complex. Most implementation relies on WebSockets, but GraphQL specification doesn't specify the WebSocket protocol. So the most popular one is Graph-WS protocol. It is the one implemented by Strawberry Check. However, AWS AppSync use a slightly different one. Hopefully, Strawberry Check is extensible, and we've been able to implement our own WebSocket protocol to interact with AppSync. So Strawberry Check can use our own implementation. So that's pretty cool. Sorry. So now let's take a look at the code.
So switch over.
Yeah. Just type in my password. All good. All good. So first, this is the dashboard. So here the screen is a bit too small. So, whoops. Let's remove this. So Python, so this is the live data. So Python is definitely the winner of the week at the most, the favorite programming language, but C# is third.
There's a back, right?
So this is the application. So let's take a look at the solution. So the dashboard solution contains three projects, but we will focus mainly on the web project, which contains the Blazor WebAssembly. So let's take a look quickly at the project. OK. So here, it's basically a Blazor WebAssembly, a standard Blazor WebAssembly project. I've defined a carousel display component, so you can see. We will take a look at it. And you can see some GraphQL file here. So Strawberry Check uses this GraphQL file to automatically generate the client library for me. So I don't have to write the boilerplate code to request my GraphQL API. Strawberry Check automatically generates all this boilerplate code for me. So that's pretty awesome. I've saved so many time because I was updating my GraphQL schema, and I just have to rebuild my my project, and it was updated. So pretty cool. So let's take a look at my program file. So how I set up everything. So first thing, I set up my dependency injection. So here I'm adding an HTTP client that will request on my base address. If I'm not on debug mode, so if I'm in prod, I would request my configuration on my base address plus the config path to dynamically retrieve my configuration, because I don't want to hardcode my configuration for production. But here we are on my laptop, so I'm in debug mode, and I basically set up my API key and my API URL. So let's take a look. Here in the AWS console, I can go into settings. So this is the AWS AppSync console, and I can retrieve my API URL and my API key here. And here in the schema section, you can see my GraphQL schema. So this is where I've defined my GraphQL schema, very basic. And here, I can go to my, for the field poll results, I can go to my vote data source. And here I'm just defining, OK, my vote data source is bound to my DynamoDB table. And I will just run a scan operation on my DynamoDB table on the answer count index. And I will just return the result of my DynamoDB table request to the client. That's it. So once I've retrieved this, here I'm adding an extension method provided by Strawberry Check to configure my GraphQL client object. And for my client object, I'm configuring the HTTP client transport layer and the WebSocket client layer. So I told you that I've overridden the default WebSocket protocol. And here, this is how I'm setting up this. I'm defining for the iSocket protocol factory interface, I'm giving my own implementation of the factory, and this implementation of the factory provide WebSocket protocol class compatible with AppSync. And that's it. So here in my here in my component object, so you've seen the carousel. So I'm using the mud carousel component, and in this mud carousel, I'm just setting several carousel items, once for each question. But the most important part in this code is the onInitialize async method. So this method is called the first time your Blazor component will be created. And here I'm calling the load data method. So let's take a look at this method. So here I'm using my default GraphQL client object provided by the dependency injection. I'm using the getPoll results property, and I'm calling the execute async method on it. I retrieve the response. I can check for the errors on the response object, and then I can just parse the result and then prepare the data for being rendered. And that's it. So very easy to use the GraphQL client. I don't know anything about how Strawberry Check handles the requests. I'm fine with this. It has automatically generated all the boilerplate code for me. Same things. So here, after loading the first data, so because finally I'm just querying the data the first time when I reach the page, and after the dashboard is updated only through notification through the WebSocket protocol. So here, this is what I'm doing. I'm subscribed to update in this method. So to subscribe to the update, I'm just using the onPoll result update properties, called the watch method, and subscribe to this operation. And in the subscribe operation, I give a callback method. And this is the same. For the callback method, I check for errors, I check if the data are well formed, and then I just update the data, the rendering, and that's it. And here you can see that I'm calling on my Blazor component, I'm calling the invoke async method because the notification won't happen in the UI thread. So I want to synchronize with my UI threads because AppSync, when the notifications come, it comes into another thread, so I want to synchronize with my UI thread. And that's it. So that's how it works. Let's come back to the slide now. So, Derek, I'll let you wrap up.
Alrighty. So we've walked you through the client, the backend, and the dashboarding. We've showed you some code. We've showed you how we did it. The pitfalls that we had to get through, and the end result. But what did we learn? What are the key takeaways from the last 55 minutes? Well, IoT Core in .NET and MQTT is really, really easy. We showed you the class that did it, It's just plain old MQTT. You use the MQTT .NET library, job done. You can run .NET 6 functions. It's possible on AWS Lambda, and it's really, really easy if you use the CLI Lambda tool extension. You can also leverage the AWS SDK for .NET to interact with AWS services, such as Amazon DynamoDB. And you can use AWS AppSync to host a GraphQL API and consume it with Strawberry Shake to get that real-time notifications into, as we did, the dashboard. All of this is possible, and we've just showed you how. However, we didn't get everything. We had a time boundary of reInvent. These are the things we would add if we had more time. So I spoke at the start about adding user authentication is the preferred way of securing the client. We'd get to that. We'd also build in monitoring. Obviously, observability is everything. This is a demo app for a conference, so we didn't implement observability as well as we should have. And we would have done that using CloudWatch and X-Ray. We could have built automated testing using device farm. I would build that as well if this is a production-style app. And we didn't do a build and deployment pipeline. Obviously, that's a no-brainer. Because if we had to build this in production, we would need to get new client versions out pretty quickly and fix bugs even quicker. However, we have a code. This code, if you scan it, will give you all the links to help you build a similar app like we did. How to get started on .NET is the .NET homepage. There's a GitHub repo on the .NET applications and AWS white paper. We also have training certification links for .NET and Pluralsight courses as well. So everybody take a scan. Also, we'll be here if you want to ask questions. Obviously, you'll be talking to the engineers who built this, so we can go into quite a bit of depth if you want to do so. But all in all, it's very clear from this talk that we bloody love .NET. I'm from Australia, I can say that. And I hope that's come across over the last 58 minutes. So thank you all for staying and listening. I hope you all bloody love .NET as well. And please give some feedback on this app. Come talk to us. And we might give you some stickers as well, because we've got some stickers already. Thanks very much. And we'll see you next time.